What if the atoms that built your body are not as stable as they seem? What if, hidden within each of them, lies a ticking quantum time bomb, silent, invisible, inevitable? Chapter 1. The illusion of stability. We live surrounded by things that seem solid. The desk beneath your hand, the walls that hold your room in place, the ground under your feet. Everything feels firm, dependable, permanent. But that's only the story our senses tell us. Beneath the surface, the truth is far stranger. If we could shrink down to the scale of the atom, the illusion would break instantly. Matter isn't still. It never rests. It flickers, vibrates, and dissolves into waves of probability. At the smallest scales, there is no such thing as silence or stability. Even in perfect emptiness, something is always happening. Tiny bursts of energy appear and vanish again, creating brief, invisible storms inside what we call nothing. This restless activity has a name: quantum fluctuation, the trembling of the universe itself. And it's not rare. It's everywhere. Inside every atom of your body, the same dance unfolds, again and again, millions of times each second. The particles that make you are constantly blinking in and out of certainty. A century ago, when scientists first looked into the atom, they expected to find tiny, hard spheres, little building blocks of reality. Instead, they found clouds. They found energy, uncertainty, and patterns that looked more like music than machinery. It was a shock that changed everything. Werner Heisenberg, one of the founders of quantum theory, realized that you can never know both where something is and how fast it's moving. The more precisely you try to see one, the more the other slips away. This was not a problem with our tools. It was a law of nature. Reality itself refuses to be pinned down. So what does that mean for us? It means that stability, the feeling of a still, quiet world, is not the truth. It's a comforting story told at human scale. Underneath, everything vibrates with invisible motion. If you could zoom in far enough, even the chair you sit on would look like a ghost, a mesh of energy fields, endlessly shifting. Atoms are mostly empty space. Their electrons moving so fast that they only seem solid when averaged over time. You aren't sitting on a chair. You're floating above it, held up by electrical repulsion, by fields that never actually touch. Every moment, the world is being rebuilt from scratch. Physicists sometimes describe the vacuum, the fabric of space itself, as the true foundation of reality. It looks empty, but it holds enormous energy. This sea of background energy gives birth to all particles and forces. Everything we see is a temporary ripple on that surface. Imagine a calm ocean. Now imagine that, beneath the calm, there are constant unseen waves colliding and dissolving. That's our universe. It only appears still because the chaos is too small and too fast for us to see. This constant vibration isn't random noise. It's the reason we exist at all. Without it, matter could never have formed. Stars, planets, even light, all depend on these restless fields. Yet there's something unsettling in that thought. If everything is built on motion and uncertainty, how does anything stay? Why doesn't the world collapse back into chaos? What keeps all this trembling from falling apart? That question led scientists toward one of the most haunting ideas in modern physics: metastability. The idea that the universe might not be as stable as it looks, that it might be sitting, quietly, in a temporary state, safe for now, but not forever. Before we reach that thought, let's stop and reflect. Every object you see is a blur, frozen in time. Every breath you take passes through molecules that have existed for billions of years, rearranged endlessly. We're made of patterns, not permanence. There's a strange beauty in that fragility, because if nothing is fixed, then everything is possible. The same instability that threatens destruction also allows creation. Without it, the universe would be lifeless and cold. Think of the stars. Each one burns because quantum uncertainty allows atoms to fuse. Each photon of light is born from that same trembling energy. What we call chaos is the heartbeat of the cosmos. But we humans are built to crave certainty. We want to know that the ground beneath us will hold. So we build our worlds, our homes, our memories, our plans, on the hope that tomorrow will look like today. And most of the time, it does. Yet deep down, physics tells a colder story. It says that even the laws themselves might shift one day. That stability is not a promise, only a pause. If we step back far enough, the entire history of the universe is a chain of transformations. Energy becoming matter, matter collapsing into stars, stars dying, scattering the elements that become us, from chaos to order, and back again. Every heartbeat, every atom in your blood, is part of that vast oscillation. The illusion of stability is not a lie, it's a mercy. It allows consciousness to exist in a storm too deep to comprehend. So, when you touch a surface and feel its weight, remember what's underneath. You are touching motion. You are touching uncertainty frozen into form. You are, in a way, touching the vibration of the void itself. And that brings us to the next question, the one that keeps physicists awake at night. What if the trembling never truly stops? What if, hidden inside this endless motion, there's a deeper instability, one that could shift the entire universe into a new state? Because some theories suggest that everything we see, all matter, all energy, even the vacuum itself, might not be the lowest possible state of existence. It might just be a temporary plateau, a false calm before a fall we can't imagine. The illusion of stability might one day end, and that is where our story begins. Chapter 2: Metastability. The universe's hidden state. Everything in the universe seeks balance. A ball rolls downhill until it settles in a hollow. A spark burns out when it runs out of fuel. Atoms find stable configurations, and stars burn until gravity and pressure reach equilibrium. We call this balance stability. But in nature, not all balance is permanent. Some states only look stable until the right disturbance comes along. Imagine a marble resting in a shallow pit. It's not rolling. It's still, but just above it lies a deeper valley. The marble doesn't know that yet. It feels safe where it is. Then, a small nudge, and it rolls over the edge, dropping into a lower, truer state of rest. That is something appears calm, but it's only temporarily so. It's balanced but on borrowed time. In physics, metastability is everywhere. Atoms, molecules, and even large systems can exist in this in-between state, stable enough to last, but not forever. Ice can remain frozen even above its melting point, until a small vibration melts it completely. Metastable states are like whispered promises. I'm fine, for now. But what if the universe itself is metastable? To understand this, we need to step beyond atoms and into the strange world of fields. Everything in existence, particles, forces, even space, is made of fields. You don't see them, but they're everywhere, filling the entire universe. An electron is a ripple in the electron field. Light is a ripple in the electromagnetic field. And deep beneath them all lies something even more fundamental, the Higgs field. The Higgs field gives mass to matter. Without it, particles would fly through space at the speed of light, never forming atoms, stars, or you. This field is the quiet stage on which reality performs. But what if that stage isn't perfectly flat? What if it, too, sits in a shallow valley, stable, but not ultimate? In the late 1970s, physicist Sidney Coleman and his collaborator Frank DeLucia explored this terrifying idea. Their paper was called The Fate of the False Vacuum. It asked a question few dared to consider. What if the vacuum, the lowest energy state of the universe, isn't truly the lowest? What if it's false? Imagine that the entire universe rests in a shallow bowl of energy, the false vacuum. Below it lies a deeper bowl, the true vacuum. We can't see that lower state because we're trapped in the upper one. Everything we know, matter, light, space, and time, depends on this false balance. But if a single point in space were to tunnel through the barrier, if it somehow found a path to the deeper state, everything would change instantly. A tiny bubble of true vacuum would form. Inside that bubble, the laws of physics would be rewritten. Outside the bubble, everything would vanish. and the bubble would expand at the speed of light. No warning, no explosion, no sound, just the smooth rewriting of reality itself. Coleman's calculations were purely theoretical. He wasn't predicting doomsday, he was describing what the math allowed. But the thought stayed. Even decades later, scientists still debate whether our universe sits in such a metastable state. The discovery of the Higgs boson in 2012 deepened that question. Its measured mass suggested something strange. The Higgs field might indeed be metastable. In other words, the energy of our vacuum isn't the absolute minimum. It's close, but not quite. Now, before panic sets in, physics also tells us this decay, if it can happen, is incredibly unlikely. The timescale is unimaginable, longer than the lifetime of stars, galaxies, or even protons. It's so far beyond human comprehension that we might as well call it forever. But that doesn't make it less haunting, because the possibility exists. And possibility alone changes how we see everything. Think about it. We live in a universe that could, in principle, dissolve into something else at any moment. Without any warning, without any trace, every star, every thought, every memory gone, rewritten by new laws we can't imagine. Not burned or broken, just unmade. It's not a story of fire and destruction. It's a story of transition. A quiet change in the code that holds everything together. If that ever happened, no signal could outrun it. No one would feel fear or pain. It would be instant. We wouldn't even know. One moment, the universe is here. The next, it's something else entirely. This is the kind of thought that leaves scientists awake in the dark, not because it's likely, but because it's profound. It forces us to face a deeper question. If even the laws of physics can decay, what does stability mean? What does existence mean? When Sidney Coleman spoke about this, he didn't sound afraid. He laughed, actually. He said the idea was so huge, so far beyond human concern, that it was almost comforting. If it happens, no one will ever notice. No one will ever know. There's a strange peace in that thought. It reminds us how small we are, and how temporary our sense of permanence really is. And yet, that fragility makes life more precious, not less. Because everything we love exists in this narrow window, a moment of balance before the marble rolls again. We live between two valleys of energy, balanced on the edge of probability, and somehow, it works. Metastability isn't just a scientific concept, it's a metaphor for everything alive. We exist in states that seem stable, relationships, memories, worlds, but all are temporary. All can shift with a small change, a subtle vibration. In the end, even the universe follows the same rule. Nothing lasts forever, not even the calm that seems eternal. And perhaps that's what makes existence meaningful. Not its permanence, but its fragility. Because when you realize the ground beneath you might not last forever, every moment suddenly matters. How fragile is existence when even stability is an illusion? When the laws of physics themselves might contain their own undoing? The answer isn't in fear, it's in awareness. The universe has always been changing, and so have we. We are made of the same uncertainty. We are, each of us, a temporary pattern in an unstable cosmos, and somehow, that's enough. Next time, we'll dive deeper into the structure of this instability, into the quantum heart of the so-called time bomb inside every atom. Chapter 3. Inside the quantum bomb, the story of the universe begins not with stars, but with fields. Invisible seas of energy stretch across all of space. Every particle you've ever heard of, electrons, photons, quarks, is just a ripple in one of these fields. Reality, at its deepest level, isn't made of things, it's made of expectations. The solid world you touch is not solid at all. It is a dance of disturbances in a cosmic ocean. Among these fields, one stands apart, the Higgs field. It's everywhere, woven through the fabric of existence like an unseen mist. As particles move through it, they acquire mass, their resistance to motion, their weight in the cosmic sense. Without it, matter as we know it could not exist. Atoms would never form. The universe would be nothing but endless light. For decades, the Higgs field was theory, a mathematical ghost. Then, in 2012, at CERN's Large Hadron Collider, the ghost appeared. A faint signal, buried in mountains of data, confirmed it. The Higgs boson, the field's messenger, was real. The discovery was hailed as the final piece of the Standard Model, proof that our understanding of reality was almost complete. But hidden inside that triumph was a warning. When physicists calculated the Higgs boson's mass, it came out strangely balanced, precariously so. It suggested that the Higgs field, the invisible ocean holding everything together, might not be perfectly stable. In fact, the numbers hinted it could be metastable, resting in a temporary valley of energy, not the deepest one possible. Meaning, the universe itself might be standing on a false floor. To understand how dangerous that is, imagine this. Inside every atom, fields hum quietly in equilibrium. The Higgs field sits at a specific value, a kind of tension between creation and collapse. Every interaction, every vibration, every spark in the quantum world depends on that number staying exactly as it is. But if that value were to change, even slightly, everything would unravel. Matter would lose its meaning. Mass would dissolve. The forces that bind atoms would fall apart. In theory, all it would take is one microscopic shift, one quantum fluctuation tunneling through the barrier of the false vacuum to create a tiny pocket of new reality, a true vacuum. Inside that bubble, the Higgs field would settle into a new value, lower, stable, final, but it would be a universe incompatible with ours. Atoms could not exist there. Light could not travel the same way. Chemistry, physics, life, all rewritten. The bubble would expand at the speed of light, consuming everything. No noise, no flash, no warning, only transformation. This is what physicists sometimes call the quantum bomb. Not a weapon, but a metaphor. A chain reaction written into the fabric of existence itself. Not born in laboratories or stars, but in the subtle instability of the Higgs field. Each atom, each field excitation, is stable because the vacuum allows it to be. But if that vacuum were to change its rules, then even the most stable element, even the quietest atom, could become a messenger of annihilation. Let's be clear, there's no sign this will happen. The universe is unimaginably old. If the Higgs field were truly unstable, the decay should have already occurred somewhere, sometime, over billions of years. But the math allows the possibility, and that possibility alone is enough to unsettle. The idea transforms the smallest thing, a single field value, into a cosmic loaded gun. And it reminds us how absurdly fragile existence really is. In quantum field theory, everything that exists is part of a continuous whole. There are no true separations, no isolated systems. Every particle interacts, even faintly, with every other. So if a decay did begin, if one small region transitioned to a lower energy state, the process could not be stopped. It would cascade, silently rewriting reality as it expands. An apocalyptic chain reaction born from something smaller than an atom. It's poetic, in a terrifying way. The very equations that explain why the universe exists also contain the seeds of its destruction. But perhaps the most chilling part, isn't the destruction itself, it's the scale of indifference. The universe wouldn't choose to collapse. There would be no reason, no intention, just probability, just physics doing what it always does, following the path of least energy. And in that sense, the quantum bomb isn't really a bomb at all. It's a mirror. It reflects how we see meaning in a system that never promised it. Think of the first atoms after the Big Bang. They formed from chaos, from fields stabilizing after unimaginable energy. And for billions of years, those fields have held steady. They've let galaxies form, planets cool, and life emerge. But all of that depends on a delicate balance of numbers, values that could, in theory, drift. One change, one fluctuation, one quantum event, and the balance ends. The smallest truths can unmake the greatest realities. That line is not just philosophy, it's physics. It means that even the tiniest structure in the fabric of existence holds infinite consequences. A shift in a single equation could erase the entire stage upon which reality stands. And yet, the fact that it hasn't happened might be the greatest mystery of all. Why is the Higgs field stable enough to last this long? Is there something deeper keeping it in place, a hidden symmetry, an undiscovered law? Or are we simply lucky, living in a cosmic moment between two eternities? When you zoom out far enough, it's humbling. The stars, the galaxies, even time itself, all of it depends on a value buried inside the heart of the quantum world. Our entire existence is balanced on a decimal point. That fragility doesn't make life meaningless. It gives it weight, because every heartbeat, every breath, every thought is happening in a universe that could, at least in principle, vanish without sound. And yet, we are here. We are the noise inside the silence, the vibration inside the vacuum, the fleeting pattern of order that stares back at the infinite. Maybe the universe isn't waiting to collapse. Maybe this balance, fragile, improbable, temporary, is what keeps it alive. A metastable existence that allows thought to emerge just long enough to ask these questions. Perhaps that's what consciousness is. The universe looking at itself, wondering how long it can stay awake before it falls back into perfect stillness. In the end, there's nothing frightening about that. There's only all the quiet realization that even instability can give rise to meaning. We exist inside the quantum bomb, and it hasn't gone off. That, in itself, is a miracle. Chapter 4 echoes across the multiverse. There's a thought that whispers through modern physics. It says, our universe might not be the only one. For centuries we assumed existence was singular, that all of reality began with our Big Bang and ends wherever the last photon fades. But the deeper we look, the less certain that seems. Quantum mechanics, inflation theory, and string cosmology all hint at something larger, a multiverse. Not a fantasy realm, but a vast cosmic ocean where universes appear and vanish like bubbles in boiling water. Each universe begins as a fluctuation, a random, violent swelling of space. Energy expands, cools, and stabilizes into its own version of physics. Each bubble may hold different laws, different constants, even different kinds of matter. Some universes might collapse in an instant. Some might last forever. Ours happens to be one that balanced long enough for stars and thought to emerge. But what if others weren't so lucky? If vacuum decay is possible here, it's possible anywhere. And if the multiverse exists, an infinite sea of universes with different energy states, then the process of decay might already be happening elsewhere. Picture it, an endless cosmic landscape, scattered with lightless remnants, dead universes, extinguished by their own instability, each one silenced in an instant, its fields rewritten, its history erased. No explosions, no afterglow, just absence. We can't see these fallen worlds. They leave no trace across the walls that separate one universe from another. Their silence is perfect. From our perspective, they never existed, and yet, somewhere beyond our cosmic horizon, the echoes continue, the expansion of decay bubbles that will never reach us, the fading ripples of creation undone. It's a haunting image, a multiverse littered with invisible tombs, each one the aftermath of a quantum collapse. Physicists sometimes call this picture the landscape of vacua, a theoretical map of every possible configuration of space and energy. Each valley on that map represents a universe like ours. Some valleys are deep and stable, others are shallow, resting on thin ledges of metastability, always one quantum fluctuation away from falling deeper. We might be in one of those shallow places, and across the infinite, others have already fallen. In the early moments of the Big Bang, inflation, the violent expansion that created space itself, may have never stopped completely. Instead, it could still be happening endlessly, spawning new regions of space-time every instant. Each one inflates, cools, and forms its own reality. This process is called eternal inflation, a multiverse of birth and decay, expansion and collapse. Everywhere, Bubbles of creation rise and fade, each blind to the others. Ours is just one of them, a flicker among countless flickers. And yet, this raises a quiet question. If the multiverse is infinite, and universes are constantly being born and dying, does the end of one universe even matter? When something infinite loses a part of itself, does it feel the loss? Perhaps endings only mean something to the beings who can remember them, to the particles that can think, fear, and hope, even for a short while. To us, quantum tunneling, the same process that could end our universe, is not destruction in the usual sense. It's transition. It's movement through barriers that classical physics forbids. In quantum terms, even what seems impossible still has a non-zero chance of happening. Given enough time, infinite time, every possible event will occur somewhere. Every collapse, every rebirth. So perhaps every universe that falls gives rise to another. Perhaps decay is not death, but transformation, the endless recycling of existence through deeper and deeper states of energy. Maybe there are infinite versions of us scattered across that landscape, each living out a slightly different reality. Some where the constants of nature are shifted, some where life never formed at all, and some where the bubble has already arrived. It's strange to imagine that in the infinite silence beyond our sky, other universes could already be gone, erased before they were ever known. And stranger still to think that their absence makes no difference to the whole. The multiverse doesn't grieve, it doesn't remember, it simply is. From its perspective, every loss is just another note in an eternal pattern, an infinite song made of creation and collapse. If that's true, then the story of our universe isn't one of tragedy. It's one of brief awareness, of being awake inside a dream that almost never forms. We exist, for now, on an island of improbable balance. The vacuum hasn't fallen. The constants still hold. The fields still hum in harmony. And maybe that's enough. Because when you look at it this way, survival isn't about living forever. It's about existing at all. It's about being conscious within the flicker, even if the flicker is short. If the multiverse truly is infinite, then awareness, this fragile spark of observation, becomes the rarest phenomenon of all. It may appear for only a moment in the endless dark, and yet that moment defines everything it touches. Perhaps that's why we look to the stars, not to escape death, but to understand it, not to deny impermanence, but to find beauty inside it. If the universe ends tomorrow, the memory of its existence will still echo somewhere, not as sound or light, but as probability, woven into the infinite fabric of what could be. Every act of thought, every spark of wonder, leaves a trace, a ripple, across the field of possibility, an echo across the multiverse. Maybe that's what meaning really is, not something we create, but something we notice before it disappears. A reflection that says, we were here. The universe may be one breath among countless others, and that breath may one day stop. But for this brief interval, it speaks through galaxies, through particles, through minds. And we, for reasons we'll never understand, get to listen. Chapter 5. The fragile miracle. For all the terror hidden in quantum physics, there is also something profoundly gentle, because the same instability that could destroy the universe is also the reason it exists. Without uncertainty, there would be no creation, no motion, no stars, no life. If the laws of physics were perfectly still, if every particle stayed exactly where it was, the universe would be frozen in silence. No time, no change, no thought. It's the imperfection, the trembling, that makes everything possible. In the first moments after the Big Bang, quantum fluctuations rippled through the newborn cosmos. Tiny differences in density, smaller than atoms, became the seeds of galaxies. Without them, the universe would have remained smooth and empty. It was randomness, pure, chaotic, quantum noise, that drew the first patterns of order. The stars were born from instability. So were we. Every atom in your body carries that legacy. Hydrogen forged in the early universe, carbon and oxygen made in dying suns, all of it sculpted by the restless fluctuations of the vacuum. the same restlessness that still vibrates inside every atom now. So when we speak of a fragile universe, we're really speaking of a masterpiece held together by tension, a balance between chaos and structure, between randomness and design, between destruction and creation, and somehow, against impossible odds, that balance has lasted long enough for something like us to appear. We are conscious matter. We are the universe, briefly aware of itself. Every observation we make, every act of noticing, is the cosmos studying its own reflection. That's not poetry. That's physics. Because observation, at the quantum level, changes the system being observed. Consciousness itself is woven into the equations of reality. So maybe we're not just spectators in this cosmic drama. Maybe we're participants, threads in the fabric that holds it together. Think about this. The vacuum might someday decay. The Higgs field might shift. The constants of nature might rewrite themselves. But the chances of that happening within the lifetime of stars are so small, so impossibly distant, that for all practical purposes, our universe is safe. It has lasted for nearly 14 billion years. It will likely last for trillions more. The slow fade of starlight will come long before any deeper instability does. So fear isn't the right emotion. Wonder is, because we exist in a universe that could have collapsed 1,000 different ways, but didn't. Every breath you take is proof that the cosmic dice rolled in our favor. Look around you. Every color, every sound, every heartbeat is an echo of quantum motion, ancient, delicate, unstoppable. You are not separate from it. You are made of it. And when you feel small beneath the stars, remember, those stars only shine because instability allows fusion to happen. Their light, their death, their rebirth, all come from the same fragile balance that sustains us. The universe is not perfect. It's alive. Science tells us that everything changes, that even the constants of nature might not be constant forever. But maybe that's not a flaw. Maybe that's the most beautiful thing about existence, that it moves. Perfection is static. Life requires motion. So perhaps the universe's fragility is what makes it beautiful. Because only through instability can there be time. Only through time can there be growth. And only through growth can there be awareness. We often ask, why is there something rather than nothing? Maybe the answer is simple. Because nothing can't feel wonder. Because even the void wanted to know itself. And so it flickered. Once. And from that flicker came everything. You, me, the stars, the galaxies, all part of a temporary pattern written into the trembling of space. That pattern will fade. But for now, it holds. And within that fragile pause, something extraordinary has happened. Awareness has bloomed. We can see the instability. We can name it. We can love it. Maybe that's all meaning ever was, the moment when the universe looks at itself and feels gratitude for existing. Because to exist, even briefly, in such a volatile cosmos, is a miracle worth witnessing. Thank you for watching. If you wish to keep wandering with us through the quiet edges of the universe, like, subscribe, and share your thoughts below. Until next time, stay curious. If this story left you thinking, leave a comment, share your thoughts, or subscribe to journey deeper into the mysteries of existence. Until next time, stay curious, and stay awake beneath the trembling stars.